Welcome to a special edition of Rift Amps. This has just come through the door. The customer contacted me last night and said he's had this amp for years, decades, but it's been in his attic for at least 25 years and hasn't been plugged in and turned on in that time. He wants to get this thing going so he can use it and play it. What is it? It is a Laney Sound 70 watt pre-supergroup, we believe, 4 input. I think it's the PA head. He seems to recall that this is a 1968 model. Now, if anyone knows the Laney history, you know Laney started in 1967, and for, I think, the first 3 years, they were all built by Laney himself in his garage. So this is a very early Laney amplifier that hasn't been turned on in a very long time. So, what are we going to do? Well, he wants to use it, he wants to play it, he wants to get it going again. So we're going to do a resurrection, not a restoration, a resurrection, like we did on the Sound City, which is go through it, make sure it's safe to turn on, and then do everything required to get this thing going. It doesn't mean recovering it and, making it look brand new. He wants to keep it looking, for the age that it is. But it does mean we can do things like clean up the panel, remove the dust, things like that. So yeah. This is a really rare, exceptionally cool amplifier that we get to bring back to life. So here we go. Hasn't been turned on in 25 years. Let's do this. Right, so looking at the rear of the amplifier, we can see we've got a multi-tap primary, 110, 210, 230 and 250, which is set at 250. It's got a mains fuse. Mains input is a Bolgin, which are now outlawed, can't use them. So I'm going to have to remove that and fit an IEC socket. Now this is a special IEC socket that is designed to fit into that hole. It'll probably get sideways like that. So I don't have to enlarge or drill any extra holes in the chassis itself. So that's what we're going to do. HT fuse, it's got an 8 ohm or a 15 ohm, 16 ohm selector and 2 outputs. It's got some tape on it, which is covering a sticker that says 60 watt, not 70 watt, 60 watt, okay. Can't read what that sticker says. The serial number on the chassis has faded, but on the rear plate it is there, 3X1032, Laney Sound Systems Limited. So that's the rear of the amplifier. The cabinet itself is in pretty good condition. It's not bad. It's not covered in mould or anything like that. Just needs a good old clean, as you can see. I'm going to turn it up on its side. Sorry, I've got to do this one-handed. There we go. And you can see it is unfortunately missing its feet. So we're going to have to put some feet on there. He's already authorised us to do so. And the ones I've got, you can see, I don't know if you can see there, the outline of the original feet. The ones I've got appear to be the same diameter. So a couple of nicks in the cabinet. Tolex, sorry. But overall, it's in pretty good shape. Those knobs are cool. Right, let's get the back panel off and see what we can find inside. So just one thing to note is that the top two screws on the back have cut washers, but the bottom two are missing. So we'll make sure we put those back the way we find them. Right then. So let's take this rear panel out. And what do we see? We see some partridge transformers. 1, 2, 3. Mains transformer, output transformer, and choke. Cool. Right. This tape doesn't seem to be doing anything. Was it just holding the in place? Right. Hopefully we can get in and see. It's not too dark, but we've got a label behind. See if we can find any dates on it. It tells you who signed these things. ML. Is that Mr. Laney himself? Possibly. Right. Overall, it's in pretty good condition, isn't it? But I want to remove the chassis from the cabinet so we can have a look inside. Right, I didn't think that chassis was going to come out yet then, because these bolts and nuts, you can see there's some surface rust on them, and some of them were extremely tight. I almost thought we were going to strip those and we weren't going to be able to get that out, but we did. So looking at this label, that's what I wanted to look at. Batch number 194, I don't know what that means. Chassis, connect and test all seem to be by the same, and the assembly actually, by the same chap, ML. Is that Mr. Laney? I suspect it is. So the choke is a Partridge unit TG9688, I think. The output transformer, JG9686. You can see the G is different from the 6, that's why you know it's a G. And the power transformer or mains transformer, TG9685. A full set of Partridge transformers. Now, interestingly, I found another one of these amplifiers for sale on Reverb and eBay by a dealer in the UK, and he's posted some internal shots, and that one doesn't have a full set of Partridge transformers, whereas this one does. I'll include some pictures now to show you. So reading on some forums, I understand he was experimenting at the time with different brands of transformers and things, depending what he could get and what he'd like the sound of. So that kind of confirms that theory, at least so far. Let's look at this EL34. HRS. That one appears to be the same, doesn't it? Yeah, I can't see any writing on that one. Right, so should we do it together? Let's turn this thing upside down. I haven't looked either, so I have no idea what the insides look like. Let me just set the tripod up and we can have a look in real time together. Okay, so let's start at the power transformer end. we can see our mains input, our fuses, our voltage selector, of course some wiring, our on-off and standby switches, our dual light. Okay, so what do I see? It looks to be almost untouched, at least at this end. The Erie filter caps have bulges on both sides. Can you see? There and there. And then we have the same on the other side. This one's starting to go. This one. Slightly. This Hunt's filter cap here looks to be okay, but you know, if we're going to try and protect those partridge transformers, then we need to look at that. This one appears to have been changed before, because that's not original. So at some point, somebody came along and fitted and swapped out that filter cap there. Very cool. So it is almost virgin. Let's look along the front panel. What can we see? Does that solder joint look like it's been messed with? Possibly. None of the pots look different from the others, so they could possibly all be original. Very interesting. Now, I don't have a schematic for this amp, and a quick look online doesn't reveal one either. So I think now is a good time to, or at least this, one of this amplifier is in, to reverse engineer it, draw the schematic out for other people that might want one. But to be honest, they're not complicated amplifiers. You've got 4 inputs, probably all driving a single triode, mixer stages, phase inverter, output stage. So, right, so what's my plan of attack on this then? Well, it's going to need the Bolgin replacing with an IEC. I want to swap out all the caps. Actually, that one's been replaced as well, hasn't it? Is that in the bias supply? Yes, I think so. We'll do all of them. And once I've got all those done, I can, like I did with the Sound City, soft start it on the bench, bring it up, take measurements, see where we need to go with things. But I don't think this one is going to take much to get going. So our Resurrection on this Laney PA amplifier, did I say 60 or 70? 60 watts. It shouldn't be all that too complicated. Okay, so fast forward actually a couple of weeks now. It's been 2 or 3 weeks since I shot the last couple of scenes. So I finally managed to get round to starting the job proper on the Laney. So I've got all of my replacement filter caps. So we're going to go through and we're going to swap all of these out. So the 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we're doing 9 of them. Got to do the Bolgin as well, as I said, and then we can fire it up and see where we are. But yeah, I'm going to go through and just swap all these caps out. And any resistors that look like they've had a hard life or are out of tolerance. So yeah, that's what I'm doing this afternoon. Right, so that's all of the caps electrolytic caps replaced, apart from the 4 cathode bypass caps for the preamp valves, the first 2 stages. Got the Bolgin plug replaced with a IEC. Now I'm just going through because everything in the amp is grounded, so I've got the I've just connected to the center pin, so my continuity meter. So when it beeps, we know something is grounded. So, and we can go through and we can check that where we expect there to be a ground, there is. There's one. And that one's grounded. Now the only one, this one here, nothing. Nada. Now why is that? Why is that not grounded when everything else is? And this is why you've got to be careful. Obviously I've replaced this cap and I've touched that turret, and all the green wires in the amp are grounds. And that one has come loose. So we need to reattach that, make sure we get a good ground there. And then I think I'm comfortable in firing this amp up. However, I've noticed something. Whilst everything that should be grounded should be, I can go through and I can touch everything. It should be grounded. The chassis itself is not. There is no earth safety bond. I cannot get this amplifier. I cannot find an earth connection for this chassis. So what I'm going to have to do to bring this up to code is disconnect the main ground bus from this socket and then ground it to the chassis, and then have a separate earth safety bond from here to the chassis as well on a separate point. Have to make this amplifier safe. Yeah, but yeah, that's the only thing I can find now. So just resolder that ground wire there, and then I mean, for testing purposes through my gear, I don't need to sort the safety earth out, but I will do that afterwards. Right, okay, so as this amplifier doesn't have a chassis connection at the moment, I've connected my meter to B minus, as we're going to call it, so the negative side of the B plus rail, which does, it does connect to our earth pin of our 3-prong plug, but the chassis itself is not connected. So I'm just having to bear that in mind. We're going to be firing it up through our light bulb limiter. This is a 100 watt bulb at 240 volts. Easily enough to do the maths. It's a maximum it allows is around 330-ish milliamps of current to flow. And I'm just going to monitor the HT rail at the first node using my meter. So this is potentially the first fire up for this amplifier in quite a long time. So switches are in the on position. I'm not going to be touching anything metal. All I've got to do is hit my switch here, and then we can start to see what happens. Now, if this bulb glows full brightness, we know there's a short straight away. But what I do expect to see is it to glow slightly, dim down. Then I'll see the high voltage come up on the meter. In fact, that would be pretty instant because it's solid state rectified. Then as the valves warm up, I expect to see the bulb start to glow more, but not at full brightness. Just want to make sure I explain this to you properly. Then I expect to see the HT voltage, the B plus, start to come down. So are we ready? Let me just get this set up. Let's go. So bulb went slightly bright and now has dimmed down. I've got 400, over 500 volts, 520 volts, 530, 540. But don't worry, I've got a 1000 volt totem stack there. So, and there you go. As the valve starts to conduct, the B plus starts to drop as the bulb starts to increase in brightness again. So at the moment, I'm pretty happy with this. Now, usually when I fire any amp up with the light bulb limiter, as I'm doing now, I usually get around 35 to 40 watts consumption from the wall, which is about where we are. So what I'm going to do now is I'm just going to leave this to settle. We're checking for smoke, of course, things like that. Check that I can't see anything wrong. Our indicator bulb has come on. I can see the heaters. Just see the heaters in the valves. In the output valves. I haven't checked the preamp valves yet. But all in all so far, pretty good. Now what I can do with my voltmeter is I can start to go through and check that I've got voltage where I want there to be voltage. And the first one I'm going to do is check that there is a bias voltage. This is the bias circuit here going to my output valves. And there you go, I've got a negative voltage there of negative 36. Now that won't be what it is when I give the amp full voltage, full mains voltage, but there is a negative voltage there, which is a good sign. So it shows me that circuit is working. And in fact, if I come actually measure on the output valve itself, on pin 5, there's our bias voltage, and actually hear a signal coming through the speaker, which is a good sign. So I can just go through and check the rest of my B plus rail, check that I've got voltage where I expect to see it. Crucially, I want to check there's not voltage where I don't want to see it. For example, here, plate resistors for V1. I expect to see a couple of 100 volts there. That's what I've got. And on the other side, there you go, same again. But on this side of the caps, these should be blocking all DC. So if I touch there, I shouldn't have any volts. And there you go, I've got less than 4 millivolts. And on the other one, about the same. So those caps aren't leaking. Right, so I'm just going to leave this to settle down for a bit. Again, it hasn't been fired up for a long time, but I can actually hear some hiss coming through the speaker, so I know it's starting to do something. But I'm just going to leave that for 5, 10, 15 minutes. Go back through, check all my voltage again, and if it's okay, I might inject a signal and see if we can get anything on the scope. So far, so good. Okay, so update time. The amp's been running actually for about half an hour now, and I've just gone through, checked the voltages, all seem to be okay. So what I've done is I've injected a signal into the front end of the first input, well that's input 4, isn't it? Anyway, this one goes to V1A, and then what I'm doing, but what I'm not getting, sorry, is any output on the oscilloscope. So what I've done is with my second channel, I'm now tracing the signal through the circuit as I usually do when I'm diagnosing amplifiers. So that's at the socket, the input socket. This is at the grid, and then coming out, much larger signal. Other side of the cap is my signal, goes up to the volume pot. There's my signal. Other side of the volume pot, it's there. And then from there, it goes to one of the mixer resistors. There's my signal. Gets attenuated down slightly. There it is. And from there, it comes on this white wire into our cathode follower tone stack, and there's my signal. Now, I'm not getting any output from this valve. There's voltage on it, but I can't find my signal. The signal goes into the valve, but doesn't come out anywhere. So it's not appearing past this valve. So we have found the point where our signal disappears. Now, I've just been looking at these valves. Let's get you out of the way. And just by touching them, I can tell that that valve is on. That's warm. That valve is warm. But this one, I don't think this one's on. I can barely, there's nothing in there. That's cold. Same with maybe the phase inverter's on. Maybe. But I think our cathode follower is dead. I don't think this valve is working at all. I think she's dead. So let's stick another ECC83 in that position, see if it comes alive. Okay, so I think it was just poor pin contact, because it's now coming back to life. In fact, if I get my I've now got an output coming out. It doesn't look very healthy, but there is an output there. But I can, bear with me, I'm tangled up here. I've now got signal coming out of the cathode follower, which is now making it to the input. Just slow that, shrink that down a bit. Input of my, gosh, huge. That's a huge signal. There you go. Phase inverter input. There it is. There she is. Right, phase inverter output. Purple we're looking at, yep. Oh, very quiet on that side, look. So we need to check what's going on with one side. I think that's why we've got a one-sided sine wave there. But we're now passing signal all the way through the amp. It's just working out what's going on there, on where and why things are working. But yeah, that was an easy fix, that one. It was just the poor pin, can't even say it now, poor pin contact. Look, in fact, it's disappeared. If I wobble it, it disappears. There you go, it's come back now. And it's gone again. I think we need a new socket. I think it's a new socket time. That's a shame. There you go. Yeah, I did try another valve and it was the same issue. So I think that socket needs replacing. I think it's just worn out. Okay, so that's my first job. I need to get that consistent, and then I can start looking at the rest of the problems. Okay, so new socket installed. There's the old one. I did try retensioning the pins, but it's just too far gone. So a new belt and socket in place, and if I wiggle the valve now, we don't get any cutouts. So that's that. At least that's now fixed, and we can move on to the rest of it as to why we've only got half the sine wave. Now, if you remember, if we look at the signal going to one side of the turn yellow off, then you can see. So coming out of the phase inverter, one signal is good and the other is pretty much non-existent. So we need to, so on this side it's good, on this side it's not good. So we need to investigate what's going on here. Coming out of the phase inverter, we've got good signal on the good side, no signal on the bad side. So what's going on with our phase inverter? That's the next thing to investigate. Okay, so I've now got a full signal. So each output valve is now conducting, and I didn't do anything. I didn't do anything at all. But I think V4, the phase inverter socket, suffers the same problem as V3 did, because I can wiggle it around. There you go, and it starts to play up. In fact, if I can get it into a certain position, and our signal just disappears. Look, yeah. So I'm going to try cleaning this socket first of all, and if it doesn't come back, we're going to have to replace it. So it's now the next day. I've replaced the phase inverter socket, again, a new Belton, and we now have full output. Look at that, beautiful. 21.2 volts RMS into 8 ohms gives us 55, 56, 57 volts, something like that. 60 watts will be 22 volts RMS. So, I mean, we're pretty much there at 60 watts, aren't we? I need to check bias and things and go through it, but we've now got an amplifier that's running well, passes signal all the way through, and is giving me the output that it's rated for. So again, I'm just going to double check the operating conditions, tweak the bias if necessary, and then we can leave it to soak in. But this amplifier is, I reckon it's nearly done. Just got to do that safety earth, give it a good service, clean all the pots, bits and pieces like that. But yeah, this Laney is coming along quite nicely, and it should be able to go back to the customer very soon. So here's our pile of victims, as it were. First thing first is the old Bolgin socket. Can't have these in the UK anymore, won't pass the PAT test. They're also incredibly dangerous, so we have to, if you want to have this amplifier serviceable, you've got to remove them. The two sockets, this was the cathode follower for the tone stack, that socket, that one's done. This was the phase inverter, again all gone, and these are the filter caps in the amp. Now you can see they're starting to bulge and starting to leak. Let me zoom in. So whenever you look at electrolytic capacitors and you start to see a bulge mark there by the vent, you know they're on the last legs. And for the cost of the cap versus the cost of replacing the transformers, it's always worth doing. So that one's gone. That one's the same. That one's the same. That one's the same. In fact, that one's probably the worst of the lot. This 8 microfarad cap actually looks okay, but while you're in there, get it replaced. If you're doing all of them, this 16 is going, and this other 16 just starting to go as well. So all of those caps needed to be replaced really, especially if we want this amplifier to work again. Plus, you know, if they haven't been charged up for 25 years or whatever it was, who knows what their performance is. I mean, you can go through and test these for ESR, things like that, but honestly, it's cheaper just to replace them and protect the amplifier, which is what we want to do, especially those cartridges. So yeah, that's the pile of victims. It did obviously have some more modern replacements already fitted, but whilst you're in there, get them done, get them out, get them sorted. So he'll get all of those back with the amplifier, so he can, if he does sell it, he can pass those on. or he can chuck them in the bin. That's entirely up to him, but I certainly don't want them. Right, let's crack on. Okay, so the amp is now on the bench. I've gone through it, I've given it a service. I'm happy with where it's running and everything like that. So we're just going to give it a quick play test. So I've got my Vickers Les Paul, which is the single P90 carved top, like that. Treble, middle, bass and presence all at 5, and I've got the volume control turned reasonably high, and I'm just going to use the volume pot on my guitar. Start with the cleans and we'll just bring it up. But so a bit of crunch there, stays relatively clean. I mean, there's not a lot of gain stages in it anyway, but noise floor is very low. Any noise you hear is just pick up itself. Yeah, nothing wrong with that. So I've tried all 4 inputs, sounds great. Really happy with it. Bung it all back together and the customer can have it. Job done. The only other thing I'm going to do is just run the looper through it, and rather than using the volume control on the guitar to clean it up, we'll just increase the volume pot on the amplifier so you can hear how it overdrives as we turn up. So I've got our standard Ainsley Lister loop running through it, and you'll be able to hear what it does. So that's the amp all done. I really hope you enjoyed this one. I have. This is a classic resurrection job on an amplifier, not a restoration. Difference between the two is this one is just about getting this thing up and running and working, and then the customer can decide whether he wants to keep it or sell it, or who knows. It's not about going through it with a fine-tooth comb, you know, to that level of detail. Just a resurrection, get it up and running. It'd been sat for ages. I think he said, was it 10 years or was it 25? I can't remember. I have to look back at the start of the video. Anyway, but that's now done. I'm going to leave it soak testing just to make sure we've got no other issues with it. Stick it back in the cabinet, give it a quick clean, and all done. So thank you very much for watching. Give this video a thumbs up, comments down below. Number of ways to support the channel, as I've mentioned before. Easiest way is just to subscribe. Please subscribe to the channel. It really, really helps. But you can, if you want to support the channel financially, you can do hitting the join button below this video, or you can just do the super chat, super comment function if you wish. Of course, that's entirely optional. It's not compulsory. You don't have to do it. Don't feel pressured. But there you go. And I shall catch you all on Sunday.